numerical number 1, F1 equal 5 Newton, the second force F2 is equal 20 Newton, and two forces are acting at an angle 120 degree. That's why theta is equal 120 degree, and we have to find the resultant force, magnitude of resultant force and direction. That's why R equal question mark and phi will be equal question mark. So here two forces F1 and F2 are acting at an angle 120 degree. Along OP the force F1 is acting, along the direction OQ the second force vector F2 is acting. Taking F1 and F2 as two adjacent sides of a parallelogram, we can draw a parallelogram OPSQ. Along this diagonal, resultant force will be acting along OS. OS is the diagonal along which the resultant force vector R will be acting, and two forces are acting at an angle 120 degree. That's why theta equal 120 degree, and R equal root over F1 square plus F2 square plus 2 F1 F2 cos theta. 2 F1 F2 cos theta. R is equal root over F1 square plus F2 square plus 2 F1 F2 cos theta equal root over 5 square plus 20 square plus 2 into 5 into 20 into cos 120 degree is equal root over 425 plus 200 into minus half, where cos 120 degree is minus half, is equal to root over 325. Therefore, R is equal to 18.03 Newton. R is equal to 18.03 Newton. This is the magnitude of resultant force of two forces having magnitude 5 Newton and 20 Newton acting at an angle 120 degree. R is equal to 18.03 Newton. That is the resultant force. The resultant force vector R acts at an angle phi dash with the direction of larger force vector F2. Vector R acts at an angle phi dash with the direction of the force vector F2. Therefore, tan phi dash will be what? What will be the expression of tan phi dash, where phi dash is angle between R and F2? As phi dash is measured with the larger force F2, that's why the larger force F2 is the first force and F1 is the second force. That's why tan phi dash is equal to F1 sin theta divided by F2 plus F1 cos theta. Now putting the expression, we get what? F1 is 5 Newton, that is 5 into sin theta, or 5 into sin 120 degree divided by 20 plus 5 into 1 cos 120 degree. So 5 into root 3 by 2 divided by 20 plus 5 under bracket minus half. Finally, we get 5 root 3 divided by 15. 5 root 3 divided by 35. It should be 5 root 3 divided by 35. Finally, we get tan phi dash as equal root 3 by 7. Now, root 3 by 7 is equal to 1.732 divided by 7. And dividing this, we get 0.247. We get tan phi dash as equal root 3 by 7. Therefore, phi dash is equal tan inverse root 3 by 7. Phi dash is equal to tan inverse root 3 divided by 7. Therefore, phi dash is equal. Therefore, phi dash will be equal 13.898 degree. Phi dash is equal 13.898 degree. Therefore, phi dash is equal 13 degree 53 minutes. So F2 is acting and F1 is acting at an angle 120 degree with F2, and we can denote the resultant force. Resultant force vector R acts at an angle phi dash is equal 13 degree 53 minutes. Resultant force vector R acts at an angle phi dash is equal 13 degree 53 minutes with the direction of larger force vector F2. Hence, phi dash can also written by 13 degree 53 minutes 52.39 seconds. Hence, the resultant force vector R acts at an angle phi dash is equal 13 degree 53 minutes 52 seconds. With the direction of larger force, with the direction of the larger force F2 equal 20 Newton. With the direction of larger force F2 is equal 20 Newton. The resultant force vector R acts at an angle phi with the smaller force vector F1 equal 5 Newton, and 5 may be greater than 90 degree. 5 may be greater than 90 degree, and vector R makes an angle phi dash with the direction of larger force F2. Phi dash is equal to 13 degree 54 minutes. That's why we can find phi as theta minus phi dash. That will be 106 degree 6 minutes. Let vector R acts at an angle phi with the smaller force vector F1. Vector R acts at an angle phi with the direction of the smaller force vector F1. In this case tan phi, will be what? And here phi is measured with respect to smaller force F1. That's why F1 is first vector or first force, and F2, the larger force, is second vector or second force. Tan phi is equal to F2 sin theta divided by F1 plus F2 cos theta is equal to, now putting the values, that is 20 into sine 120 degree divided by 5 plus 20 into 1 cos 20 into cos 120 degree, that is 20 into root 3 by 2 divided by 5 plus 20 into minus half, and finally we get 10 root 3 divided by minus 15, 10 root 3 divided by minus 5, and that will be tan phi will be minus 2 root 3. Tan phi will be equal to minus 2 root 3, and we have to find the value of phi. As tan phi is negative, that is minus 2 root 3. That's why phi can be written as 180 degree minus tan inverse 2 root 3. Phi is equal to, if phi equal to 2 root 3, in that case phi will be acute, but tan phi is minus 2 root 3, which is negative. That's why phi, the angle phi, will be obtuse angle, and we have to consider this concept, that is phi will be 180 degree minus tan inverse 2 root 3, that is 180 degree minus 73.89 degree. Finally, we get phi as equal 106 degree 7 minutes. That means phi is equal to 106 degree 7 minutes. Numerical number 3. The first force F1 equal to P plus Q. Second force F2 equal P minus Q. Resultant force R equal root over 2P square plus Q square. And we have to find theta, that is the angle between the two forces. The magnitude of the resultant force, is given by R equal root over F1 square plus F2 square plus 2 F1 F2 cos theta, or comma R square is equal to F1 square plus F2 square plus 2 F1 F2 cos theta, or comma, in place of R, what we can write? In place of R square, we can write 2P square plus Q square equal P plus Q whole square plus P minus Q whole square plus 2P plus Q P minus Q into cos theta, or comma 2P square plus Q square is equal to 2P square plus Q square. In place of P plus Q plus P minus Q square, we can write 2P square plus Q square plus 2P square minus Q square cos theta, or comma 0 equal 2P square minus Q square into cos theta, or comma 2P square minus Q square cos theta is equal to 0. Therefore, cos theta is equal to 0. Cos theta is equal to 0. Therefore, theta is equal to cos inverse 0. Theta is equal to cos inverse 0. Therefore, theta is equal to 90 degree. Theta is equal to 90 degree. Therefore, theta is equal to 90 degree, which is the answer. Hence, the two forces F1 and F2, that is two forces P plus Q and P minus Q, act at an angle of 90 degree. Act at an angle of 90 degree with each other. Numerical Numerical number 4. Given f1 equal a plus b, f2 equal a minus b, and r is equal root over 3a square plus b square, and we have to find the angle theta. That means theta equal question mark. Now we know that square of resultant force, that is r square, is equal to f1 square plus f2 square plus 2f1 f2 cos theta, or comma, in place of r square we can write 3a square plus b square, which will be equal to a plus b whole square plus a minus b whole square plus 2a plus b into a minus b cos theta, a minus b cos theta, or comma, 3a square plus b square is equal to, here we can write 2a square plus 2b square, 2a square plus 2b square plus 2 under bracket a square minus b square cos theta, or comma, after simplifying we get a square minus b square will be equal to 2 a square minus b square equal cos theta, or comma, cos theta is equal to 1 by 2. Therefore, theta is equal to cos inverse 1 by 2. Theta is equal to cos inverse 1 by 2. Therefore, theta is equal to 60 degree. Theta is equal to 60 degree. That means two forces will act at an angle 60 degree with each other. This is the answer. Numerical number 6. Resultant of two equal forces acting at right angle to each other is 1414 Newton, 1414 Newton. Find the magnitude of each force. Find the magnitude of each force. According to this numerical, what are given? According to this numerical, two equal forces are given and their resultant magnitude of resultant is also given. Here the magnitude of resultant force R is equal to 1414 Newton, and theta is equal to 90 degree, because two equal forces are acting at right angle to each other, and two equal forces are F1 and F2. That means F1 equal question mark and F2 equal question mark, and here F2 is equal to F1. F2 will be equal to F1. The magnitude of the magnitude of the resultant force of the two equal forces is given by R equal root over F1 square plus F2 square plus 2 F1 F2 cos theta. R is equal to root over F1 square plus F2 square plus 2 F1 F2 cos theta, or comma, R square is equal to F1 square plus F2 square plus 2 F1 F2 cos theta, or comma, in place of R what we can write, 1414 square is equal to 2f1 square, 2f1 square plus 2f1 square cos theta, using what f2 as equal f1. 1414 square is equal to f1 square plus 2f1 square cos 90 degree. Now we can draw two equal forces which are acting at right angles to each other. Vector f1 and vector f2 are the two equal forces, and we can draw a parallelogram or a square, because two forces are equal forces along this diagonal. The resultant force vector r or r will be acting. Angle between f1 and f2 is theta, which is 90 degree, because two forces are acting at right angles to each other, or comma, 1414 square is equal to 2f1 square, because cos 90 degree is equal 0, or comma, 2f1 square is equal to 1414 square, or comma, f1 is equal to 1414 divided by root 2, or comma, f1 is equal to 1414 divided by 1.414. Therefore, F1 is equal to 1000 Newton. F1 is equal to 1000 Newton. That is the value of the first force. Similarly, F2 will be equal to F1 because these forces are equal forces. Therefore, F2 is also 1000 Newton. F2 is also 1000 Newton. So, these are the answer of this numerical. According to numerical number 8, resultant of two forces acting at an angle of 150 degree is 10 Newton and is perpendicular to one of these forces, one of the forces. And here we have to find the other force. According to numerical number 8, given R is equal 10 Newton, theta equal to 150 degree and phi is equal to 90 degree. We have to find F2 equal question mark. That means the magnitude of other force F2 equal question mark. Along these directions, resultant force vector R is acting, and the first force vector F1 is acting towards right. And we can draw this side of the triangle, and vector R acts at an angle 90 degree with the force vector F1. Along this direction, the other force, that is second force F2 is acting. Along OP, the first force F1 is acting. Along OQ, the second force F2 is acting. An angle between the line of action of the two forces is theta. And resultant force vector R acts at an angle phi is equal 90 degree. Resultant force acts at an angle phi equal 90 degree with the first force F1. The magnitude of resultant force is given by R equal root over F1 square plus F2 square plus 2F1 F2 cos theta, where theta is the line of action of the two forces. This is equation 2. Now, vector R acts at right angle or acts at an angle phi with the direction of the first force vector F1. That's why tan phi is equal, phi is measured with respect to vector F1. So that's why tan phi will be what? F2 sin theta divided by F1 plus F2 cos theta is equal to, or comma, tan phi is equal to, or tan 90 degree is equal to F2 sin theta divided by F1 plus F2 cos theta, or comma, infinity is equal to F2 sin theta divided by F1 plus F2 cos theta, or comma, 1 by infinity is equal F1 plus F2 cos theta divided by F2 sin theta, or comma, 0 is equal F1 plus F2 cos theta divided by F2 sin theta, or comma, F1 plus F2 cos theta is equal to 0. Therefore, F2 cos theta is equal to minus F1. F2 cos theta is equal to minus F1, which is equation 2. Again, R is equal to root over F1 square plus F2 square plus 2F1 F2 cos theta, or comma, R is equal root over F1 square plus F2 square plus 2 F1 under bracket minus F1, since F2 cos theta is equal to minus F1. Equal root over F2 square minus F1 square. R is equal to root over F2 square minus F1 square, or comma, R is equal root over F2 square minus under bracket minus F2 cos theta whole square. Since F1 is equal to minus F2 cos theta, or comma, R is equal root over F2 square minus F2 square cos square theta, or comma, R is equal root over F2 square is taken common under bracket 1 minus cos square theta, or comma, R is equal F2 square sin square theta, since 1 minus cos square theta is sin square theta. Therefore, r is equal to f2 sin theta. R is equal to f2 sin theta, or comma f2 equal to r divided by sin theta. F2 is equal to r divided by sin theta, or comma f2 equal, putting the values, 10 divided by sin 150 degree. F2 divided by 10 divided by half, since sin 150 degree is half. Therefore, F2 is equal to 20 Newton. F2 is equal to 20 Newton. The value of second force, which is 20 Newton. F2 is equal 20 Newton, which is the magnitude of other force. F2 is equal to 20 Newton, which is the magnitude of the other force. That is the answer. That is the answer. Numerical number 10. If vector A equal vector B plus vector C, and the magnitude of vector A, vector B and vector C are 5, 4, 3 respectively, then find the angle between two vectors, vector A and vector B. According to this numerical, given vector A equal vector B plus vector C, A equal mod vector A is equal 5, B equal mod vector B equal 4, C equal mod vector C equal 3. Phi dash is equal question mark. We have to find the value of phi dash. As vector A is equal to vector B plus vector C, that's why vector A is the resultant vector. Vector A is the resultant vector of vector B and vector C. Therefore, mod vector A is equal to root over mod vector B square plus mod vector C square plus 2 mod vector B mod vector C cos theta, or comma A is equal to A square is equal to B square plus C square plus 2BC cos theta. A square is equal to B square plus C square plus 2BC cos theta, or comma 5 square is equal to 4 square plus 3 square plus 2 into 4 into 3 into cos theta. 25 equal 25 plus 24 cos theta, or comma 24 cos theta is equal 0. Therefore, cos theta is equal 0. Therefore, theta is equal 90 degree. Theta is equal 90 degree. That is the angle between the two vectors, vector B and vector C. Hence, vector C acts at right angle. Vector C acts at right angle to vector B. And here vector C is acting along this side OQ of this rectangle, and along OP, along the side OP of the rectangle, vector B is acting along this diagonal. The resultant vector, vector A, will be acting along this diagonal. Resultant vector vector A will be acting, and theta is equal to 90 degree. That means angle between C and B is 90 degree. Angle between A and B is phi, and angle between A and C is phi dash. Let vector C acts at an angle. Vector C acts at an angle phi dash with vector A. Therefore, tan phi dash is equal B sin theta divided by C plus B cos theta. Tan phi dash will be what? Here tan phi dash will be B sin theta divided by C plus B cos theta, or comma tan phi dash is equal to 4 sin 90 degree divided by 3 plus 4 cos 90 degree, or comma tan phi dash is equal to 4 into 1 divided by 3 plus 4 into 0, or comma tan phi dash is equal to 4 by 3. Therefore, phi dash is equal to tan inverse 4 by 3. Phi dash is equal to tan inverse 4 by 3. Therefore, phi dash will be equal to 53.13010235 degree. 53.13010235 degree. Therefore, phi dash will be 53 degree 7 minutes 48.37 seconds. Phi dash is equal to 53 degree 7 minutes 48.37 seconds. Hence, the angle between vector A and vector C. The angle between vector A and vector C is 53 degrees 7 minutes 48.37 seconds. That is the answer.